each equation given will be a plane like the blue, yellow, and green one. We will try to find the solution noted here as P, which is the intersection point for them.
Okay, so here, let's go ahead and try a fairly easy example. We have x equals 2, x plus y equals 3, and x plus y plus z equals 4. And notice how we have three variables. So when I get my solution to the system, that'll contain three different numbers. So notice here that we already have what x is equal to. It's equal to 2, so we could substitute that into either of these equations. But it would be best to substitute it into this equation, because then I would only have one variable left to solve for. So this x equals 2, I'm going to sub that into this x here. And when I do that, I get, for this equation, I get 2 plus y is equal to 3. And I could simply solve for y now by subtracting the 2 on both sides. So I get that y is equal to 1. And similarly, I could go back and plug this y and x into this equation, because then I would only be left to solve for z. So going ahead and plugging this y equals 1 and x equals 2 into this equation, I get that 2 plus 1 plus z is equal to 4. Only have one variable to solve for, so 2 plus 1 is 3. Subtracting the 3 on both sides, I get that z is equal to 1. So I have solved for all the variables now. So the solution to our system would be x equals 2, y equals 1, and z also equals 1. And you could also write your answer in this format. So we had x value of 2 that was given, we found y to be 1, and z also turned out to be 1. Okay, so this is our solution, 2, 1, 1, and we could always plug this back into our three equations and see if that turns out to be the case. So you guys could go ahead and experiment with that to see if that works out. Okay, here's one that's very similar to the one that we just tried. So why don't you all just pause the video and give it a shot, and then once you've came back, we'll go over it together. So this one, again, is very similar to the last one we did. We already have what a variable is equal to. Y is equal to 3, so I could substitute that into either of these equations because they both have y's. But it's best to go with this one because if I substitute y into here, I would only have one variable left. So substituting y equals 3 into this y, I get that x plus 3 is equal to 5. Now solving for x, subtract 3 on both sides, you get that x is equal to 2. Now that I know that x is equal to 2, I could jump to this equation and plug x and y in to get z out. Right? So doing that, x is equal to 2, so 2 plus y is equal to 3, plus z is going to give me 7. So 2 plus 3 is 5, plus z, that's going to equal 7. Subtracting 5 on both sides, we get that z is equal to 2. So you could write your answer in this format. So our x value would be 2, we got y to be 3, and z turned out to be 2. So this would be your solution to this system. Okay, so let's look at a slightly harder problem. Now the first thing to notice here is that we don't have a variable solved for, and in that case we can't back substitute that into the other two equations. So here, the equation that's sticking out to me is this one because it only has an x and a z contained in it, as opposed to these equations here, they have x, y, and z. So my goal for this one is to eliminate the y's for these two equations because this equation here is missing the y variable. So then if I eliminate the y's from this variable, I'll get a new equation that has z's and x's in it, and from there I could just do our normal elimination that we did with two system of equations. So to eliminate the y here, I would just simply have to multiply this equation by -6, and that would cancel out the y's for me. So I'm going to take this first equation and multiply by -6. Doing that, I get -6x minus 6y minus 6z equals negative 90 with 3 zeros. And I'm just going to leave this equation alone here. So that's 9x plus 6y plus 5z equals 89,000. Now I'm always adding these two equations. So negative 6x, we're adding it. So negative 6x plus 9x, that would be 3x. Notice the y's cancel. You get a negative z equals negative 90,000 plus 89,000 would give me a negative 1,000. So this is my new special equation now. So if you want, you could put a star next to it, or whatever you'd like. You don't have to do that, but I just do that to keep track of all my equations because it gets messy sometimes. So now this is a new equation that I want to work with. So let me just erase this. So this is the new equation I achieved, and I wanted to work with this alongside with this equation because there's a z and an x here, and there's also a z and an x here. So putting our focus on these two equations here, right? Notice that I already have what z is equal to, so I could substitute that into this z here. So I'm going to take this z and what it's equal to and substitute it into this z. Doing that, I get over here somewhere, I get 3x minus z, and z is equal to 7,000 plus x, and that's equal to a negative 1,000. So notice the whole point of that was, now that I'm left with only one variable, that's the same. So we could easily solve for that now. Distributing the negative into here, we get 3x minus 7,000 minus x equals a negative 1,000. Combining 3x minus x, that would give you 2x, and adding the 7,000 over. So let's just hold off on that step. So I just combined the like terms right now. We could add 7,000 over. So it cancels, and you get that 2x is equal to 7,000 minus 1,000, that would be 6,000. Dividing the 2 over, because it's being multiplied to x, we get that x is equal to 3,000. Okay, so we just solved for one of our variables. Now we just have 2 left. So that we have x is equal to 3,000, I could plug that x into here and get what z is equal to. So z is equal to 7,000 and x is 3,000, so plus 3,000. Z is going to equal 7,000 plus 3,000, that's 10,000. So I just figured out what z is equal to. Okay, so now that we have what x is equal to and we have what z is equal to, we could go back into one of the equations that contain 3 variables to find the last variable that we're missing. So since we have x and z, we need to find y. So either equation is fine. I'm just going to work with this one because there's no coefficients in front of it. So x is 3,000. Y is what we're trying to solve for. Z is equal to 10,000. And that equals 15,000. Getting a little offside here. Okay, 10,000 plus 3,000, that's going to be 13,000. Equal to 15,000. Subtracting over the 13,000. We get finally that y is equal to 2,000. Okay, so that's it. We figured everything out. Finally, we could put our answer in this notation if we'd like. So this would be your solution. Okay, so why don't you guys go ahead and give this a shot, pause the video and whatnot, and when you come back I'll go over it with you guys. Okay, so this equation here, notice it only has an x and a z in it, so the y variable is missing. So when I look at these other two equations, they have all the variables x, y, and z. So I want to eliminate the y's from these two equations, so I only end up with x's and z, so then I could work with it, so I can look back at this equation again and work with it. So I'm just going to put a star by this equation here, because I'm going to come back and work with it in the very near future. So here I want to cancel out the y's. The best way to go about doing that would be to multiply this equation by 5. So doing that, I get 5x minus 5y plus 25z equals negative 20. And I'm not going to do anything to this equation. So I'm just going to rewrite it. Okay, now what I'm doing is adding these two equations. So 5x plus x, that's 6x. Notice the y's cancel. And then 25 plus z is 26z. And then I get a 0 here. And then I'm going to put a star by this equation because that was my ultimate goal, is to end up with this equation so I could work with it with this odd equation that I noticed in the beginning that was missing a variable. Okay, I'm going to put these star equations next to each other to work with them now. So I have 2x plus z is equal to 0. And the other star equation, I had 6x plus 26z equals 0. Now this is just like solving the two systems of equations that we did before with elimination. So you could choose to eliminate whichever variable looks easiest to you. So I'm going to cancel out the x's here by multiplying this equation by a negative 3. So doing that, I get negative 6x minus 3z equals 0. And I'm just going to rewrite this because I didn't do anything to it. Okay, notice the x's cancel out because we're adding these two equations. And then 26 minus 3, that would be 23z equals 0. Dividing by 23, because it's being multiplied. So the 23's cancel out and I get z is equal to 0. So now I have finally just solved for one of my variables, z. So in the future when I submit my answer like this, I found this z value so far. Okay, so now that I have found z, I could go back to an equation that has z in it, like my two star equations that I have written here. Plug them into either one to see what x is equal to. So I'm going to plug it into this equation here. So 2x plus z, what we found out to be 0 now, is equal to 0. 2x is equal to 0, and then dividing by 2 because it's being multiplied. We also get that x is equal to 0. Okay, so now that we have two variables, it's always good to go back to an equation that has 3 variables in it, like one of these two. I'm just going to work with, really doesn't matter, this one. So plugging in x equals 0 and z equals 0 into this equation. Notice how if the x is going to be 0 and the z is going to be 0, I'm just left with 5y is equal to 20. And dividing by the 5, I get that y is equal to 4. So this would be my answer right here.